Hello, everyone. I'm Rod Walton, Managing Editor of Microgrid Knowledge. Our Quick Chat series today springs into action with Aron Bowman, President of ELM Microgrid and ELM Solar. ELM Microgrid is a wide-scale distributed energy resource and microgrid provider with numerous well-known projects across the energy transition, some of which we're going to talk about today. Now, Aron has been a leader in the ELM corporate family for about a decade now. Before that, he had key roles at Dell and also eServe. No surprise to say, though, that the microgrid landscape is ever evolving with many versions of what a microgrid looks like, as well as aggregated DERs. But one thing is constant. Microgrid adoption keeps growing as mission critical users such as universities, municipalities, remote commercial and industrial firms look for ways to both cut emissions and secure power resiliency. So with that, Aron Bowman of ELM Microgrid, I know we're excited to talk about the various ways that they can bring the energy revolution to mission critical sites. And let's start with this, Aron. What are some of the most impactful growth areas that you are seeing right now for microgrids?
Well, hey, Rod, thanks for having me today. Really excited
You
to
bet.
talk to you guys. Big fan of Microgrid Knowledge myself, so I'm excited that you guys are having me on. I would say we're seeing a lot of, as you said, continued growth in microgrids and adoption of microgrids and further definition and growth of even what a microgrid means. So some of the key areas that we're really seeing growth in right now are tied around EV charging. That's a big topic on everyone's plate right now. How do we handle the growth in EV charging and the adoption of the EV charging infrastructure that's necessary? The other area we see is a lot of growth with municipalities and utilities. Especially mid-sized utilities, more regional utilities, but looking at microgrids and distributed energy for substation level and distribution level. And then another really exciting area we're seeing growth in, and we've started to tackle, is stepping outside of the traditional PV and wind arena for electrification in microgrids and into thermal and a growth and a resurgence in solar thermal and renewable thermal solutions for microgrids. So that's a really exciting area of growth as well, very impactful.
Yeah, and I want to get into that because I know there's a lot going on that you guys have done on projects. I kind of want to stay on one part of that for the moment. The kind of the headwinds question, which is, what are some of the challenges that EV charger deployments face right now?
Yeah, I think the biggest area that EV charger deployments are facing right now is the interconnect challenge. You have a facility such as the one I'm sitting in that maybe traditionally only uses, let's say, 250 kilowatts of power to power the office and the building and the air conditioners and these sort of things. And all of a sudden, I say, hey, for my employees, I want to come out front here, or I've shifted to an electric vehicle fleet to deliver product to our customers, and I want to put in 20 EV chargers in front of the building. Well, all of a sudden, those 20 EV chargers just doubled or even tripled the amount of load, electrical power that I need in the building. And
Right.
you can't just drop those chargers in and plug them in. You have to have that feed from the utility, and oftentimes that feed doesn't exist from the utility and requires a very serious upgrade. So the utilities want to take a year or two to do a study, charge you to upgrade the grid into your facility. You have to invest in additional switchgear and equipment to upgrade in the facility. It's a real challenge. So I would say that interconnect challenge, the amount of power that you can get from the grid, is probably one of the biggest headwinds we see today with the infrastructure growth of EV and EV charging.
Yeah, it is, and it's a real impediment to EV adoption, I think, and things like that. So where do you see specifically microgrids providing the most value to the EV market?
I think where we're seeing and we're actively having customers engage us in supporting EV charging is that microgrids can not only can you use the energy storage piece to charge the batteries when the grid isn't being used as much, but you can integrate renewables. So you're in a building. I'm in a building with a nice large roof space. So being able to integrate renewables in to actually provide and manage the charge directly to the batteries and to the EVs from the renewables, being able to do that time of use shifting with storing the energy and then charging the EVs when they come back in for the night. And then additionally, where a big value with that as a microgrid is you get this added bonus of managing the site. So you can, with a controlled microgrid system like we offer, with our field site controls integrated, you can not only manage charging those vehicles, but you can also make sure and you manage the demand on the grid so you're not getting hit with demand charges. You're optimizing the use of any produced energy on site as far as solar, because obviously you can't control when the sun is shining. So you can't automatically tie up that the solar you're producing is going to go into those vehicles. But if you create a microgrid and can operate that way, now you have the ability to get that solar energy directly into the vehicles. Additionally, it's a resiliency standpoint, being able to store the energy to be able to charge the vehicles in a grid outage situation, as well as then use the microgrid system. All of our systems are built and designed and certified to back up buildings and provide resiliency for buildings. So now you kind of have a double whammy with you have the energy storage that's in to support your EV charging, but then also can support your operations of your business. So there's a lot of value there for especially a renewable based microgrid system.
That's great. Yeah, thank you for that. I cover a lot of this, but there's still a lot that I miss, and I don't always, a lot of us, I think, on the outside miss or may not see all the details. But so I want to talk about the difference, which is, okay, you get a microgrid to support EV charging infrastructure, but why not just use a battery? Just put a big battery on site. What's the difference, and where is the value on the microgrid side as opposed to maybe that
Yeah.
solution?
I think the things that people miss, and I see this a lot going on right now, is well, we'll just slap some additional batteries in there. Well, to put a battery on a building, on a facility, you do have to have, first of all, there's several levels of certification, safety certification, UL certification, fire code certification. So you do need to have a certified product that you're putting in, and then to be able to interconnect that battery to the grid, you have to have the controls and the integrated safety systems built into the system. And that's what we offer. We offer a full packaged energy storage microgrid based system that is grid interactive, but also can integrate with the renewables. With just a battery, you can't necessarily just automatically tie in the renewables and have that microgrid solution that we were talking about. And you're definitely not going to be able to operate in an off grid situation because there are rules around being able to uh, discharge those batteries in an off grid situation. So you do need to kind of look at the entirety of what you're trying to do. And that's what
Yeah.
we do that a lot for customers is they come in and they talk to us. We'll get that call of, hey, I just need a battery. And we kind of, okay, tell me what you're trying to achieve. Our team's very adept at that. And we'll walk through and make sure we get the optimized solution for that customer. And not in we can do that pretty quickly because we've done a lot of these, not only across the US, Canada, the Bahamas, stretching into Central and South America now, all the way over to Hawaii. So we've seen a lot of different situations with microgrids, and now starting to see a lot of different situations with microgrids tied in with EV charging. So we can help kind of guide customers through those pitfalls.
Yeah, yeah, no, those are great points, and the rules and all of that, play such a role, and not everybody knows all that, so it's great to have that voice explaining that. So it sounds like it's not just a one size fits all kind of thing. Does ELM sort of allow for when and where a standardized approach might not work, and really, what are the variables that you take into account or that you must take into account?
Yeah, it's we really try to do a blended. So like we have a set lineup of products, but we've sized them in a way, we have a 125 kW package and you parallel multiple of those together. We've got a 500 kW package, a 1 megawatt, a 1.5 megawatt package, and then you can
Okay.
parallel those and then build those. I always compare it to Lego blocks. You can build the depth of those as well. So I can say I need 1 megawatt for 2 hours or 3 hours or 4 hours, and so you can kind of, we have set packages because you have to have that for to hold those certifications, and so you can rapidly
Hmm.
deploy to customers. But we've tried to build a lot of flexibility into the product lineup because it's not one size fits all, to your point, right? So we do have some adjustability in there, and the real key for us is the energy management system that we've developed in house, our field site control system, that is our microgrid controller and the microgrid control software. That's where we're able to really provide a lot of flexibility to our customers. So, do I have solar? Am I integrating that? Do I have wind? Am I integrating that? Do I have neither? And I'm just operating off the grid. Do I have a generator? Do I have a natural gas or a diesel generator? Do I have a CHP
Yeah.
system? All these things we can integrate with our controls and drive all that through our system to provide a really flexible solution for our customers.
Oh, wow, fascinating. Yeah, I mean, you guys you got so many really interesting use cases in the islands you mentioned and stuff like that. And recently, I've actually done quite a bit of reading on this one. I'm definitely aware of the project for the microgrid in Chattanooga for the police department, Power
Yep.
to Protect. And so, tell us a little bit about that. What was unique about that, and how that approach might be scaled to other jurisdictions?
Yeah, actually, that was a really exciting project that we did with the utility EPB in Chattanooga. They're a small co-op utility in Chattanooga, and we actually did a very similar project with Vista Energy out in Spokane, Washington, as well on the Washington State University campus in Spokane. But specifically, what was really exciting about that project with EPB is the utility EPB bought the energy storage system and the microgrid control system from us, and they put that in front of the meter, but it's actually at the site for the police station, and they worked with the municipality. The 911 call dispatch center put solar on the roof, so they own the PV that's on the roof and the generating. There's also a generator there that the 911 and the sheriff's office owns. So those are behind the meter. The batteries are in front of the meter, but it all got tied together across the meter to be able to function as a microgrid. And then EPBs put reclosers in the area to be able to island off the sheriff's department, the fire station, these sort of things. So they've got a utility controlled microgrid that they've set up, and they worked in conjunction with other groups within the municipality to develop this microgrid. So it's really exciting to see kind of what can happen between the utility and the entities to really set up a fantastic resiliency situation for that key critical infrastructure for Chattanooga. So very exciting what happened there. And I mentioned another one in Vista Energy up in Spokane, Washington, did a
Right.
very similar type setup with the university campus, where Vista has batteries, put them physically on the campus, but they're owned by the utility and in front of the meter. So really exciting. We're seeing utilities start to really think outside the box. And that's where we'd love to work with some of these, smaller regional utilities because they kind of move a little quicker. Don't get me wrong, we're doing some great, exciting projects with folks like PG&E out in California on their no
Right.
wildfires alternatives. We've got some exciting projects that we're looking at with companies like Duke and things like that. But it's really interesting to see some of these smaller regional ones think outside of the box and say, what can we really do to partner in our community to provide these solutions? So we love doing projects like that. They're really a lot of fun, and they're very satisfying to work on.
Yeah, yeah, you're right. And we're thrilled to have EPB at Microgrid Knowledge Conference here in coming up in Baltimore. But and it's funny, but you talk about that with the utilities because we've heard sometimes there's resistance to that, the macrogrid versus the microgrid thing. But what I'm seeing is, yeah, I mean, utilities of all sizes, and you mentioned the cooperatives and the municipals, seem to be open to trying these things and making things work on a more localized level. So that's fascinating. Now, earlier, Aron, you mentioned the Virtue Hot HD technology that you guys have, and it's really a unique social. Well, I should say it's a solar energy technology offering some options to typical solar rooftop photovoltaic. And I know it's been done at Creighton University, go Blue Jays, and elsewhere. So can you tell us how Virtue Hot HD works and how it perhaps provides a real alternative to or for the future of on-site solar?
Yeah, absolutely. I mean, solar thermal really is where the solar industry started. But you go back into the '60s, '70s, early '80s. There were quite a few solar thermal applications. Just basically heating up water for use. But it didn't. There wasn't a really robust solution, and so there's a lot of you can go through and find a lot of systems that failed over time in the U.S. and it never really took hold. And then PV really kind of took hold and what we're going through with electrification and that sort of thing. But there's a company out of Europe called Naked Energy that ELM's partnered with. And they've really brought a new, exciting design to a solar thermal tube, and then what's going to be really a combined heat and power. It's called PVT, PV plus thermal. So it's going to be solar thermal combined with PV in one evacuated tube solution, and we're really excited about it. We started deploying the solar thermal only application here in the U.S. As you mentioned, Creighton University, Graves Hall was our first deployment. It's a 400 student freshman dorm at Creighton University. And originally, they were just going to put PV on the roof. So they had two roofs. They were going to put 22 kW of traditional PV on each roof. So 44 kW total. We looked at it and said, well, there's a large heat demand, right? Hot water. You got 400 freshmen, you're doing a lot of laundry, a lot of showers, a lot of potable hot water usage. And what's great about the solar thermal, when you talk about PV, we all know, the efficiency of the amount of sunlight, energy from the sun that's grabbed in PV is about 25% of the actual energy that's in each
Yeah.
ray of sun, if you will, is captured and converted to electricity. With the solar thermal solution, the Virtue Hot is that solution. You're capturing 75+% of the sun's energy because it's an evacuated tube solution. So in the same footprint at Creighton, where they were going to put 22 kilowatt of PV, we were able to put 70 kilowatts of solar thermal solution in the exact same footprint. So we kept the 22 kW of PV on the other roof and put 70 kW of solar thermal on the opposite roof. And what's exciting about that is there's most of the time that system is providing all the potable hot water for the building. So taking all that load that would have been, if you want to do electrification, right, you're converting sunlight to electricity, rejecting off the heat with the traditional PV, then bringing it down into an electric boiler and turning that electricity back into heat. Well, with the PV, the solar thermal solution, the Virtue Hot, we're capturing that heat right from the get-go, keeping it heat and transitioning it into the potable hot water for the building. So it's very exciting. And then the new next product that's coming out is the combined PVT, which is the Virtue PVT, which is PV plus thermal, and it's going to have integrated solar panel, electrical solar panel integrated into the tube that's still capturing the heat. So now we're talking about capturing 95% of the sun's energy in that footprint. So it's very exciting. We're looking at applications in New York right now, currently, very heavily, where you have small footprint surface area on roofs with large population within the building. So apartment buildings,
Mm-hmm.
things like this, they're trying to get to net zero. And we're digging into projects where we're showing that we can get customers 3 to 4 times further in their net zero goals with the Virtue product than what you can with traditional PV. So again, it's the right situation. It's the right solution. But and this is where we talk about ands. So what's great about it too is we can integrate it with the existing thermal infrastructure that's there. So at Creighton, they were putting in natural gas boilers, and there's other parts of Creighton that are on a steam district for the university, and we're already looking at other buildings there. We can integrate this as a preheat solution right into that. So it's not, hey, you should, it's not an or. You don't have to go
Oh,
to
yeah.
just
Yeah.
renewable. We can integrate it with the existing system. So you still have the traditional system that you already had installed, but we're reducing the usage of that. So we're cutting that, natural gas boiler usage, by 75 to 80% at Creighton across the course of a year by putting in this solution. But you still have that comfort level of having, hey, if I go through 3, 4 days of, bad sunlight, heavy storm, things like that, I've still got my natural gas boilers that are running like always. So it's a great solution to integrate to a building solution to allow people to drive towards their net zero goals.
Yeah, and I think that crossroads of all these things is really where the future's at, or is going to be for quite a long time. And we live in a industry, and there's a lot very high on pure renewables, hopes and dreams, which are great. And we're all aiming for that net zero, and there are many paths to that, right, Aaron? But many also believe that combined heat and power, CHP, is a foundation for campus energy, industrial plants, processing, etc. So you just sort of alluded to that there with the talk about the virtue and all of that. So what are your thoughts on the innovations happening and to come around CHP?
Uh, I'm a big believer in CHP as well. I think it's got a tremendous value, especially in those campus setting, large industrial settings, those sort of things. As we said, as I was just saying in the previous question, is that I really think that what we can do is add to that with renewables, right? So, what can we do to make that CHP system more efficient? So, there's quite a few projects where we've got our energy storage systems, our microgrid energy storage systems, going in with those CHP systems because a natural gas CHP system doesn't like large transitions in load, right? They don't like those
Right.
transient load changes. Well, we're using the batteries to smooth out those loads so that we can make the CHP system really happy, right? Run at peak efficiency all the time, put some of that excess energy in the batteries, use the batteries to respond to spikes in the building so the CHP doesn't get that hit, and shift its frequency and things like that. Now, I think with what we're offering with the Virtue product, being able to integrate some preheat capability, so you can size that CHP system optimally for the building. There's a lot of things that I see, and like I said, we're quoting projects right now. We've got another university we're talking to in the Midwest where they've got CHP, and we're quoting them both Virtue solution and energy storage packaged together in that microgrid application. So it's really exciting what you can do when you view it all working together, as opposed to, hey, you either have to go my way or stay going the other way, right? It
Right,
can
right.
live in the middle and get us to a much more optimal solution and a lot closer to those net zero goals. So
No, you're right. You're absolutely right. And it is fascinating. The time we live in where the new can blend with the legacy to make all of this work in a way that is dependable and improving the efficiency in solar, things like that, are just key. So with that, I think we're going to close, and I want to thank you, Aron Bowman. He's president of ELM Microgrid and ELM Solar, for giving us his time today in our Microgrid Knowledge Quick Chat. And I hope you have a great day, Aaron. Thank you so much. A lot of exciting things going on around the new solar technologies, the island microgrids, and so much more.
yeah, thanks, Rod, for having me. Really appreciate it.
You bet, our pleasure. And thanks to those who've joined us for this Microgrid Knowledge Quick Chat today. I'm Rod Walton. Have a great day, everyone, and thank you again. We'll see you soon.